All right, guys, we are going to do another video today. And today we are going to go through we've done molecular mass concentration or calculations. We're now going to do molarity concentrations and talk about dilutions and how we do concentrations in the lab. So those of you who have had chemistry, which is hopefully most of you, will hopefully remember that molarity is moles over liter. So we are doing the moles of the solute over the total volume of the solution. You didn't turn out very well. Okay, so here we go. You have 125 grams of potassium sulfate, and you have 325.6 liters of solution. What is the molarity of your solution? Okay, so the first thing we need to do is figure out the solute. The solute is the potassium sulfate. So if you remember your naming rules, potassium is in the first column, so it has a charge of +1. Sulfate was an SO4 -2, so it has a charge of -2. So to get the charges to zero out, you're going to have a charge of K2SO4. Okay, so that is the formula for potassium sulfate. Now, once we have the formula, we have to find our molar mass. So we need to do 2 potassiums, we need to do 1 sulfur, and we need to do 4 oxygens. Okay, so when we look up on the periodic table, potassium is 39.1 grams per mole, sulfur is 32.1 grams per mole, and oxygen is 16 times 4, which will give us 64 altogether. So when we add this all together, we get 174.3 grams per, let's check that. This is going to be grams per mole. So now that we have that, we can actually start our problem. So we have 125 grams of potassium sulfate, and we need to get it in moles. And we are going to use this factor. I want grams to cancel, so I'm going to put grams on the bottom. 174.3 grams of potassium sulfate will be in 1 mole of potassium sulfate. And then to finish it off, we need to have liters on the bottom. We are given liters, so we have 325.6 liters of solution. Okay, so give yourself a little bit of time. Calculate that out in your calculator. Okay, check it. When you do, you should have 2.20 times 10 to the negative 3 molar. Remember, capital M means moles per liter, potassium sulfate. Okay, let's do another practice one. So we have aluminum hydroxide. So we have 162.35 grams of aluminum hydroxide, and it's dissolved in 6,700 mils of solution. What is the concentration of the solution? So once again, we're trying for moles per liter, but we've got to figure out what our formula for aluminum is. So if we remember correctly, aluminum is a +3, hydroxide ion, OH, is a -1. So in order to zero out those charges, I'm going to need 1 aluminum, and I'm going to need 3 hydroxide groups. Okay, so there's the formula for aluminum hydroxide. When we add up the molar mass, aluminum is going to be 27.0. Oxygen, we need 3 of them, times 16.0, and we need 3 hydrogens from the 3 hydroxide groups, 1.0. So when we add that up, we get a 78.0 grams per mole for the aluminum hydroxide. So now that we're there, we can get our grams of aluminum hydroxide in moles. So 78.35 grams of aluminum hydroxide. We're going to put the grams on the bottom, so 78.0 grams of aluminum hydroxide are in 1 mole of aluminum hydroxide. Okay, so we now have moles on top. We now need to get liters. So we have 6,750 milliliters on the bottom. So if you remember, we have 1,000 milliliters per 1 liter. So this way my grams of aluminum hydroxide cancel out. I have moles. My milliliters cancel out, and I have moles per liter. Okay, give yourself a second to calculate that on your calculator. Okay, pause this video. When you are done, you should have gotten a concentration of 0.308 molar aluminum hydroxide for that concentration. Okay, let's do one more. Calculate the concentration in grams per liter of a 450 ml solution that contains 0.0762 moles of iodine. Okay, so we have our moles already and we have our milliliters already. So let's do this. So we need to have our moles on top. Moles of iodine. Remember, iodine is diatomic, so it comes in groups of 2. And then we have milliliters, 450 milliliters. I should put the 0.0 milliliter. Now, we want moles per liter, so we need to convert milliliters to liters. So there are 1,000 milliliters in 1 liter. That way my mills cancel, and I now have moles per liter. Okay, pause it, calculate that out for a second. Okay, and it says to, oh, I'm sorry, I made a mistake. Okay, it says to calculate the grams in here. Okay, so we don't need to do that at all. Let's back up completely. Let's back up. So I totally misread the question. Calculate the concentration of grams per liter if we have 450 mils containing this many moles. Okay, so here we go. Let's back up. So I'm going to actually move the decimal place right here to get me into liters, right? If I move the decimal place, that gets me into liters. So I have 0.0762 moles of iodine in 0.450 liters of solution. I want to find grams, not moles. So I need to have my molar mass of iodine. So if I remember, iodine is diatomic. Each iodine is 126.9, and there's 2 of them because it's diatomic. So I will get a molar mass of 253.8 grams per mole here. Okay, so I'm going to use that molar mass. So in 1 mole of iodine, I have 253.8 grams of iodine. So give yourself a second, pause the video. So this will give us, let's see, we have 3 sig figs here. This will give us 43.0 grams of iodine. Now, I'm not really going to do sig figs. Your calculator will give you 42.97 grams. That's close enough. Okay, number 4, determine the molarity of a solution with 4.35 moles of potassium permanganate dissolved in enough water to give 750 mils of solution. This is probably our easiest one. We have moles and we have mils. Remember, if I move the decimal place 3 places over, that gives me liters already. So I just want moles on top. 4.35 moles of potassium permanganate over 0.75 liters. Okay, pause the video, calculate that for a second. you should get 5.80 molar potassium permanganate. Okay? Now, a lot of times we are going to do percent compositions, and there are a couple of ways that we will do percent compositions. Sometimes we will do a percent composition by mass, and that's usually grams over grams. So we have our grams of our solute, or what we are mixing in, over our grams of the solution. Okay? So those are, and then of course to make a percent, we want to take that, multiply it by 100, and that will give us our mass percent. Okay? Our percent by volume is a little bit different. We will take the grams of the solute, or what we are dissolving in, divided by the volume of the solution, and multiply that by 100%. That will give us our percent by volume, okay? And then sometimes we will do a mass to volume percent. So sometimes we will do a gram, just a gram over a volume. So grams per liter or grams per milliliter. And we don't do percent, excuse me, my percent by volume is wrong. Sometimes we will do not mass, but we will do, oh my gosh, I'm making all kinds of mistakes right now. We will do volume. So we will do volume of solute. So it's usually milliliter over milliliter or milliliter over liter, something like that. Mass to volume is grams per volume, or grams per mil, or sometimes grams per liter. Okay, so those are the things that we will do. And then we have a percent, so of course all of these are going to be multiplied by 100 to give us our percent. Okay, those are pretty self-explanatory. So we're going to do some practice problems here. So what is the percent by mass? Okay, so mass, concentration of sucrose in a solution made by dissolving 7.6 grams of sucrose in 83.4 grams of water. Now remember, percent by mass is the mass of the solute over the total mass of the solution. The mass of the solution includes both the sucrose and the water. So when we do the mass of the solution, we have to add the solute and the solvent together. So our solute is the sucrose, or the table sugar. So we have 7.6 grams of sucrose. And then our total mass is the sucrose plus the water. And then we want to make it a percent, so we are going to multiply it by 100. So 7.6 divided by the sum of 7.6 plus 83.4 multiplied by 100. When we do that, we will get a mass percent of 8.35% sucrose for that solution. Okay? Number 2, calculate the mass of a solute in 10% salt solution. The mass of the solution is 350 grams. So we have the mass of the total solution right here. So if I have 10% of 350 grams, could I just do it like this? 350 grams of solution. So if I do a percent, here's how you set it up with unit analysis. So this is our solution. In every 100 grams of solution, I'm going to have 10 grams of salt, or sodium chloride. Okay? So 350 divided by 100 times 10 will give me 35 grams of sodium chloride in that sample of solution, or of salt. Okay? Percent by volume concentration of a solution. Here are some examples. calculate the volume, percent volume of a solution, so we have 20 mils of methyl alcohol and enough water to give us a total of 475. So our methyl alcohol is our solute, and then our total volume is 475. Okay, and we want a percent, so we're going to multiply this by 100%. Okay, so when we do that, this will give us 4.21% methanol, or methyl alcohol. Okay. All right, here's another one. Rubbing alcohol is commonly used as an antiseptic for small cuts. It's sold as 70% volume of isopropyl alcohol in water. What volume of isopropyl alcohol is used to make 500 mils? So if we have 500 mils of solution, if I have 100 mils of solution, 70 mils of those are going to be isopropyl. Okay, so if we do that, we're going to end up with 350 mils of isopropyl, and isopropyl is C3H8O. Okay, so when we do mass volume percent concentration, this is what we get. So normal saline is used to dissolve drugs for IV use. We have 0.92 mass over volume sodium chloride in water. So that is what we call isotonic saline. How many grams of sodium chloride are required to prepare a 35 mils of an isotonic or normal saline solution? Okay, so we're going to start off with our volume here. We have 35 mils that we need of that solution, and we can create a ratio here. Doesn't this give us 0.92 grams of sodium chloride, right? Mass per 100 milliliters of solution. So we're going to use that ratio. When we do that calculation, we are going to end up with 0.322 grams of sodium chloride that we are going to have to measure out to make that. Okay, number 4. What volume of solution would be needed to deliver 3 milligrams of a drug if the concentration of the drug in the solution was 3.5 mass per volume? So we want to deliver 3 milligrams of a drug. One of the things we want to do is we want to get milligrams out of milligrams and into grams. So I have 1,000 milligrams in 1 gram of that drug. We're just going to say this is, right, we want to deliver 3 grams of that drug. So we're going to label this whatever that drug is. And then we have a concentration of 3.5 grams of that drug for every 100 milliliters of that solution. Okay, so that would be our concentration. This way my units cancel and I'm left with a volume that I need to deliver. So when we calculate this, this will give me 0.0857 milliliters of that solution that I would have to deliver. That's a really small amount of drug. Okay? Hopefully that helps you do concentrations. Okay? So, next video we are going to do bonding, and we are going to talk about a little review of chemistry, how ionic bonds, covalent bonds, polar bonds, and all those other kind of things work. So we'll do that in the next video. See you later. Bye.